since this was set up on your recommendation, would you like to make any opening remarks?
Yes, I would like to say a few things. Also, to say a few words on generally, as Rainer has said, how this series of sessions, inter-session work of EuroDIG comes up, and that will have a dual usefulness. First, I'm going to say something that is not necessarily critical for the understanding of the presentation, and so people who will join in 2 minutes, who misses the things that I will be saying, will nevertheless not miss the bulk of the presentation, and that will allow us to start and at the same time providing the full content to the people who are joining late. So this series of things, of webinars and other activities started as a consequence of the COVID, in the sense that having not being able to do sessions in person once a year, then we have learned how to do things online, and we should have learned much earlier, but that's a different story. And that has given us the possibility, and has proven the fact that we don't need to necessarily wait for the annual event in order to exchange opinion, to provide presentations, and to continue the work that has nevertheless its peak at the annual conference, but that can be done online in order to provide a continuity between from 1 year to the next. So that's the opening statement. The second thing is that in practice, work stream, work party, whatever the name was, 16, that was at EuroDIG 2021, the session about delay-tolerant networks, had raised a lot of interest, and the proposal of having a sort of webinar that can be attended online, as we are doing today, but that will remain in the records in terms of documentation for people who are newcomers to this technology, but also for experts who want to get more out of it, more understanding. Then the idea came, and so we are starting doing this. This said, I have used the 5 minutes that are the maximum that we allow for latecomers. And so I would be keen to give the floor to Windsurf if you are ready to start your presentation, and shut up.
Thank you so much, Roberto. And I've noticed that everyone has this little 5-minute thing where we fill it with something in order to allow people to trickle in. I want to introduce my colleague, Oscar Garcia. Gossard, you want to wave at everybody. I want you to note that he's wearing a suit and tie. I think that he's doing this because of my efforts to raise the sartorial quotient of all of these meetings. Obviously, I have failed miserably, just looking at the rest of the audience. But Oscar, let me thank you for doing that. That's a special treat from my point of view. I'm going
It's my
to share
pleasure.
I'm going to share the screen, and then we will have a presentation between Oscar and me about the development of a solar system internet. There are all kinds of important policy implications associated with this effort. And this is one of the reasons that I think the EuroDIG community should be aware of and interested in the possibility that we will be talking about today. So we'll hopefully get this right. I'll share one more time.
Vint, while you share, I would, as we are in a family today, I would suggest if we exchange on the chat our emails so we can all connect with each other in the future.
Yes, that's a great idea. Well, please put that into the chat. So here we go. And let me ask if I'm audible, if you could nod your head or can you hear me?
Yes, you are.
Okay, thank you. This was one of the problems that we were having before. It wasn't clear whether I was going to be audible. So let me simply start by telling you that the solar system internet idea has evolved out of the Earth terrestrial internet. So just reminding you that one of the first major demonstrations of internet concepts of multiple networks using packet switching and interconnected by gateways, which today we call routers, was demonstrated in 1977 when I was in the Defense Department helping to run the internet program. So this was the first multi-network demonstration that we did on a global scale of the TCP/IP protocols, and it was a very successful demonstration and has led, of course, to the evolution of the internet as we know it today. This is what the internet looks like today. It's 76,000 networks that are interconnected all independently of each other, but they share the same common protocols. They decide under what terms and conditions they interconnect with each other. Sometimes there's money exchanged, most often not. And in fact, 80% or so of the agreements to carry each other's traffic are done on a handshake as opposed to a formal contract. So it's quite a remarkable development, and not one that most people would believe is possible, except for the fact that it has evolved over time into this enormous global construct. Well, in 1977, actually, let me go back to 1976. There were two landers that arrived successfully on Mars, the Viking 1 and 2 landers. And then for 20 years after that, nothing worked. There were many attempts to return to Mars, and none of them were successful until 1997, when an American Pathfinder mission landed and a little robot vehicle was used to explore a small part of Mars and to send data back. This triggered a meeting at the Jet Propulsion Laboratory among myself and several colleagues who were working on space communications. And we were asking ourselves in early 1998, what should we be doing now, that is to say then, that will be needed 25 years later, which is to say now. And we concluded that designing and building an interplanetary backbone network that was more than just a point-to-point radio link, which is all that we had used in the past for our solar system exploration, was something that we should attempt to do. And so that triggered a beginning of this discussion. It also triggered the beginning of the Interplanetary Networking Special Interest Group of the Internet Society, which I'll tell you more about in a bit. So there's Sojourner, the 1997 lander, and then others. Spirit and Opportunity came in 2004, Curiosity in 2012, and others. Here's a longer list of all the various landers that have arrived at Mars successfully, including the most recent Perseverance, along with the Ingenuity helicopter, which is truly amazing considering the very, very light atmosphere of Mars. It's about 2% of the density of Earth atmosphere, and the fact that you can get something to fly in such a thin atmosphere is pretty amazing. The orbiters are also very important. I draw attention to the fact that there are two. One is reconnaissance and the other one is Mars Express, the latter being a contribution by the European Space Agency. Both of those orbiters are being used to relay information back from the surface of Mars. That's not what their original purpose was. Their original purpose was to map the surface of Mars to figure out where the rover should go. But as you will see in a moment, they became part of the communication system that has been essential to return virtually all the data coming back from Mars since the 1997 successful landing of the Pathfinder. So this, you can see from this slide, a list of people who have been participant in the development of the interplanetary backbone network and the protocols that are required of it. That started again in 1998. When Spirit and Opportunity landed in January of 2004, the plan was to deliver data back from the surface of Mars, from the rovers, directly to Earth, to what's called the Deep Space Network at the blazing 28.5 kilobits per second. The Deep Space Network, for those of you who don't know about it, is a 3 antenna system. These are 70-meter antennas, and they are at Madrid, Spain, in Canberra, Australia, and in Goldstone, California. And they are used to capture a very weak signal coming from other spacecraft in the solar system, including the ones on Mars. Well, when they turned the radios on to transmit data back from the Spirit and Opportunity rovers, the radios overheated, and there was an immediate concern to reduce the duty cycle to avoid harming either the radios or the other instruments on board, making the scientists even more grumpy because that meant there was less data coming back. So one of the JPL engineers recognized that there was an X-band radio on board the orbiters as well as on the rovers, and that we could reprogram both the rovers and the orbiters to form a store and forward network, which is how packet switching works. And so a prototype of the CCSDS file delivery protocol was imported into the rovers and the orbiters and has been used ever since to transmit data back. It's a fairly manual process. The controllers on Earth are managing when the data is transmitted and how long it's held and when is it sent, for example, from the orbiter back to Earth. It's a manual process, but it was a perfect demonstration of the utility of having a network capability as opposed to a point-to-point radio link. And of course, in order to know when to transmit and when to receive, you have to know a lot about the orbits of the planets and the orbiters, and also where's the position of the of Mars rotation in order to correctly time the transmissions. So the beginnings of all this come in 2004, basically, with the implementation of this prototype system. Originally, in 1998, we thought we could use TCP/IP because it worked okay on Earth, so we thought, well, it'll work okay on Mars. And it turns out we started to do the math and realized that that was a wrong supposition. If you realize that the speed of light is really too slow, and you can blame Mr. Einstein for that, it's only 300,000 kilometers a second, which means it takes 7 minutes to send a radio signal to Mars and get a signal back. At best, that's when we're closest together. And when we're farthest apart in our orbits, the one-way trip is 20 minutes, and of course, the round trip is 40. And we can tell you that TCP does not work well with a 40-minute round trip time because the flow control mechanism is much more immediate. You basically say, I've run out of room, and the other guy stops sending. That only works if the sender hears the signal, I run out of room, fairly quickly. And on Earth, most of the delays are measurable in tens of milliseconds, maybe hundreds of milliseconds at most, whereas here we're talking about potentially as much as 20 minutes. So flow control doesn't work very well for that protocol. Then there's the little problem of DNS, the domain name system. And those of you who know this know that before a TCP connection can be made, it needs to find out a numerical address for a domain name. So there's a system called the domain name system. It's managed by the Internet Corporation for Assigned Names and Numbers and many other partners. You basically look up the domain name and get an IP address, and then you open up a TCP connection. Now imagine you're on Mars and you make a domain name query. It could take 40 minutes to get an answer back or more, depending on possible retransmissions. And then by the time you get the answer back, the IP address of the destination may have changed because maybe it's connected to a mobile network, it's connected to 5G or 6G or something else. So this whole thing doesn't work very well either. And the result was, as we looked at the parametric space that we're working in, we realized we were operating in a new delayed and variably delayed and disrupted environment, and we needed a new conceptual framework for protocol design. We call it delay and disruption tolerant networking. The bundle protocol is what we call the suite of protocols that support operation in this new mode of new parametric space. Name resolution is essentially delayed so that you figure out which planet you're going to, and after you get there, then you decide how to get to the actual destination. We store information in the network, unlike the internet. In the internet, if there's a packet on its way to some destination, and you arrive at a router that says, I have no path to get to that destination, the router throws the data away on the presumption that it can be retransmitted end to end in a fairly brief amount of time. But if you're on your way to Jupiter and you've got to a forwarding agent on Mars, the last thing you want to do is throw that data away because you went to a lot of trouble to get it to Mars in the first place. So we store information in the network. We can get away with that in 2021 because memory is much cheaper and there's more of it available than there was way back when the internet protocols were being designed in the 1970s. So storage in the network is a different characteristic of the DTN environment. We also had to rethink network management, and the reason we had to do that is that ping is not your friend. Ping is simply a colloquial phrase for a request for the destination to echo a packet that is just received. It's a way of finding out whether a host is up on the network. But ping, instead of being a relatively real-time thing, as it is in the terrestrial internet, could take an arbitrary amount of time, just like the DNS lookup. And so the result is it's not very useful for figuring out what the current state of affairs is. So we've had to redesign the entire network management structure to avoid the kind of handshaking and interactive kinds of designs in favor of something that's much more autonomous. And so that is another difference in the DTN protocol design. And then the last point on this slide, I remember in 1998, as we were discussing this, I said the one thing that I wanted to avoid was a headline that said 15-year-old takes over MarsNet. And I was very worried about that. So I ended up arguing that we should introduce strong authentication of all the devices in this interplanetary backbone network, and also to introduce encryption so that confidentiality and command and control could be protected. And so those are the characteristics, among others, of the bundle protocol, and they are essential to its operation. And they are, of course, the things that distinguish it from what we would call the conventional TCP/IP design. I'm not going to go through every one of these bullets, but I want you to appreciate that since the 2004 period, a great deal of work has been done to refine the protocols, to refine their specifications, to implement them, and to test them in a variety of different environments with the assistance of other space agencies. So NASA, ESA, JAXA, and CARI, the Korean Space Agency, are all actively involved in this work. And are continuing to pursue implementation and deployment in various and sundry situations that will let us, I would say, convince ourselves or gain confidence in the readiness level of the technology. So as you can see, we've done a number of tests. The last two on this slide are important because they showed that the bundle protocol could be done in real time as long as the actual latencies were low. And so we were steering a robot, I should say one of the astronauts on the International Space Station was interactively steering a robot in Germany in real time because the delays between the space station and Earth are quite low because it's only a few hundred miles away. But at the same time, we were also concerned about high bandwidth. And so we did a laser test using the bundle protocols at 622 megabits a second to an orbiter around the moon and back to Earth. And so that gave us confidence that these protocols could span over a substantial operating environment, including the one at the first bullet there, which is 81 light seconds away, using the deep impact spacecraft, which NASA permitted us to reprogram. I have to tell you, reprogramming something that's 200 million miles away is the most, amazing experience imaginable. So these are just more examples of things that have been going on. Perhaps the most important thing is standardization of the protocols, and that's been done in parallel and in coordination between two bodies, the Internet Engineering Task Force, which has the DTN Working Group, and the Consultative Committee on Space Data Systems, which is made up of all of the spacefaring nations, and they are standardizing these protocols for use in space applications. We've also had the benefit of an unusual test of the DTN concept with the Luleå University in Sweden. They have a project that's been going on since 2008 to use DTN protocols in order to track the reindeer in the Arctic region that are managed by the Sami reindeer herders. And so that project has simply reinforced our belief that DTN concepts are important to situations where connectivity is uncertain and not even predictable, unlike the case where we're able to calculate the orbits of the spacecraft and planets. And so we have a way of predicting when contact is possible. Here you have to do it in a very opportunistic way, and the protocol continues to work well. There continues to be a lot of work in this effort. As I mentioned before, the various space agencies are actively involved. There is an implementation of the bundle protocols that has been done at the Jet Propulsion Laboratory, and those have been now put into operation on the Google's cloud, the Microsoft Azure cloud, and the Amazon AWS cloud in anticipation of doing some terrestrial testing at scale using the cloud-based systems to support the bundle protocol interactions with programs that might be running in a laptop or desktop or possibly a mobile or other devices like the Raspberry Pi. Some of you may remember something called the Search for Extraterrestrial Intelligence. And that effort involved a piece of software that they called SETI at home. It basically, you could download a piece of software in your laptop, and you could essentially analyze the radio signals that the SETI antenna was picking up, and to look for possible regularity in the signal. And if you found something that looked unnatural, that is to say regular as opposed to random, you could raise your hand and say, I found something. So we're thinking that we might do a similar kind of thing with SSI at home, the Solar System Internet at home, where people could run software in their laptops or desktops or mobiles to exercise the bundle protocols and give us confidence that our network management is capable of operating at scale, and that the security of the system is as we expect it to be, and that it can handle the increased amount of traffic that such a deployment would imply. At the present time, we and others who are working in this, especially the space agencies and the private sector, are starting to prepare implementations for use in the missions that return to the moon, for example, Gateway and Artemis in the US, and of course, ultimately to Mars and beyond. I'm going to introduce the Interplanetary Networking Special Interest Group in the next slide, I think, and in a moment we'll have a chance to hear from Oscar Garcia, who has a key role in the IPN-SIG work. Just to emphasize, the IPN-SIG is kind of an interest group that wants to be helpful, but I want to emphasize that a huge amount of the actual development work of these protocols has been done by the space agencies themselves and not necessarily by IPN-SIG, except that a lot of the individuals who are participant in the space agency work are also members of the Interplanetary Networking Special Interest Group. So let me introduce this. We founded this in 1998 in anticipation that ultimately this would be of some interest. And of course, 25 years later, we can see that there is. Here's something I'm super happy about. We have 800 members in this special interest group, and they are all over the world, as you see, very distributed. I believe this is unique among all of the special interest groups or chapters of the Internet Society. We have just very global, very distributed membership, and the level of interest is extremely high, not surprisingly. So our vision at IPN-SIG is simply to expand networking to interplanetary space for the benefit of humanity. That's our proposition. We've organized ourselves into a number of working groups, the strategy working group, which is looking at how do you actually do this? How do you actually build an interplanetary backbone? Oscar is going to tell you about the pilot projects that he has underway to test these protocols and to improve their stability and increase our confidence in their utility. We have an outreach activity, web pages, and the like. By the way, membership is free. Anyone is welcome to join. Just go to ipnsig.org. Scott Burley, who is the man who developed the ION implementation of the bundle protocols, has just retired from JPL. He's our vice chairman at IPN-SIG and is very much engaged in helping to document all of this and accumulate information about the protocols and their history. Yosuke Kaneko, who's with the JAXA, Japanese Space Agency, is our chairman. And as you see, he leads both the strategy group and the architecture and governance group, which is still being formed. We're asking ourselves, how would you manage an interplanetary backbone? Who will have what responsibilities for which aspects of it? And then finally, we're wondering about the commercialization of space and how the backbone network might be used to support that commercialization, as well as further exploration and research. So I'm going to turn the microphone over to Oscar Garcia to tell you a little bit about the project working group. And I hope, Oscar, that we can make sure that your microphone is unmuted. So please go ahead.
Yes, if you can hear me well.
We can hear you.
Perfect. Thank you, Ben. Well, the group, the project working group, pilot project working group is has been working, developing different research experiments and some operational applications. As Vinton commented before, one of the topics was at first connecting clouds, all cloud system, Amazon Web Services, Azure Cloud, and Google Cloud are basically working in TCP/IP, and we started to make connections between using DTN between the clouds. That was the project that is still running, but we were successful with the Dr. Lara Suzuki, that is in London, one of our engineers, and she works a lot with us in several projects with Vinton and myself. We made in last November, nearly a year ago, this connection. And I'm going to share in the chat and later send in an email, because there are several diagrams that we developed that are interesting for everybody to have ideas and to give us more ideas about this. Another topic that is very important is the interoperability between the different DTN implementations. As Vinton also commented, there is the ION implementation, there is an implementation from Germany that is now starting to be used in Europe, that is D3TN. But there is the implementation of the space agency, the European Space Agency, the ESA. There is another implementation for several others. So one of the topics is how to connect these these implementations between themselves, they are basically following the rules that are defined in the RFC 5050 and others that were developed after. So and their current version is the bundle protocol version 7. So what we want is to make this interchange information between themselves without problems, because that's what's going to happen. We are setting up with a cluster to make this first testing now in Utica College, and we are going to do that in clouds as well. We some members, Dr. Bull, myself, Dr. Alberto Montilla, that are members from the group. Other topic is routing between the different endpoints. So how to reach from one place to the other, from one endpoint to the other. You see the members there, Montilla and Montillo Joa, that are father and son. We call the Albertos. They are they are a good group. There's another group that have been working in security in DTN with Dr. Burley, Scott Burley, that is one of the developers of the ION and the version that is used by GPL NASA. Mr. Scott Johnson. We have another member, David Terrazas in Manitoba University in Canada. Another topic that is very important is related to the development of applications like the Solar System Internet at Home, the SSEI at Home, and several other products, is to develop interfacing between programming languages and DTN. So that's something that we are very fond of having, like the collaboration of any programmers that would like to be part of this. We are setting up a global testing plan in a technical way that I'm also going to share. We have several volunteers now. This system can run even in a laptop. For now in Linux yet, but it can run later. We will like to run in other operating systems that would allow to exchange bundles. So is the information of DTN between different endpoints in different parts of the world. Now we have in the United States, some of the attendees here today are already registered in this plan. In that way, we're going to distribute the software, and they are going to change. We are going to start connecting with each other. We also, in last May, members of this group, we did a testing with the OPSAT, the satellite for experiments that is going around the Earth by the ESA, the European Space Agency, and images that were taken by the satellite were sent to the Earth. They were processed with the Google artificial intelligence, and they were recognized, and all this happened on DTN and with different implementations. So there was ION, there is the GPL version and implementation, at DTN is German implementation, and they connected, and there was a lot of information coming and going, and the satellite took an image that said that it was, for example, the sky and clouds, and the artificial intelligence recognized that and turned that into words, all running around. So that was one of the projects that we are very, very happy that it worked so well. It's now Lara Suzuki, Dr. Suzuki, and the GPL, they have developed with Lee Torkenson, that was one of the original creators with Vinton and Scott Burley. They are developing Dtn controlled robots and also Internet of Things connection. I know some of the attendees are part, and Vinton some days ago was very happy about the demonstration that was made with that. So perhaps he would like to make some comments later. Well, there are some Dtn applications that have been developed by members of the group. That one is I am directly involved. That's medical record for space exploration. We developed this application, and we tested that. Even I tested that with my doctor, running on Dtn from his computer, from the simulated space station, running on Dtn down to Earth to my doctor computer. My doctor computer made a diagnostic and sent back to the space the recommendations of what to do. So we were very happy about that. And he was quite amazed that it worked. One other important project, and here is Samo and I think Maria Uden, they are both in the call. They are following reindeers in the Arctic with Dtn and with and also helping this work for the Sami community that is in the north of Sweden. Some will show for sure some antennas covered by ice. That's very challenging for communication to work. And another technology developed by a Spatial Corporation that is from the Alberto, Dr. Montilla and Dr. Montillo-Joa and Engineer Montillo-Joa, they have been developed a system for first responders in situations of emergencies. You know that when you have an emergency, you lost the communication. So Dtn is also very useful in Earth in situations because you have problems with mobiles when you have, for example, a flooding or fires or that kind of situation, the communications break. So Dtn can also be very useful in Earth, and we also are thinking in connecting Earth and space, and Earth and locations where the internet, regular internet, is not so stable or has disruptions. Well, that's more or less the idea. I'm going to on the projects we are working. I'm going to share several links in the chat during the rest of the call. And I please, Vinton, you can follow up with your presentation. Thank you.
Well, thank you so much, Oscar. You can all see, I think that there's a lot of activity here, all of it aimed at improving the confidence that we have in these protocols. So let me draw your attention now to the report that the strategy working group issued in June this year, describing how such an interplanetary backbone might actually evolve. And as you can imagine, not only are there technical things to be concerned about, but there are all kinds of policy issues associated with who runs it, how are the endpoint identifiers assigned, do we need something kind of like the Internet Assigned Numbers Authority, but which is assigning endpoint identifiers in the interplanetary backbone. There is an organization which is part of the CCSDS called SANA, which essentially would be the moral equivalent of the Internet Assigned Numbers Authority, except this would be the Space Assigned Numbers Authority or Endpoint Identifier Authority. So that report can be downloaded from this particular URL. So I encourage you to have a look at it if you have not already done so. This is just a little chart drawn from that report, which suggests that while the initial backbone network might be operated by a coalition of space agencies, we already are seeing interest in the private sector in space operations and will have need for communication. We're seeing that with, of course, SpaceX and Blue Origin and some of the other commercial sector organizations that are beginning to explore near space, and in the long run may be part of a much broader exploration of the rest of our solar system. Ultimately, perhaps it's 100 years from now, the entire space communication activity may be more like the internet is today, which is largely operated on a commercial basis with a few special cases for government and for academic communication. I want to make sure there's some time for discussion. I did want to mention that having gotten to the point where we think we understand how we might deploy a solar system internet, some of us began asking, should we start thinking about a mission to Alpha Centauri? And of course, there are some big challenges associated with that. Propulsion is a big issue because with the current available rocket systems, it would take 76,000 years to get to Alpha Centauri, which is sort of a long time. So there's a lot of consideration of how to make higher speeds possible. Then there's navigation. Normally, you know, when you're doing this sort of thing in the solar system, you do mid-course corrections, which take hours, minutes to hours in order to interact with the target spacecraft to tell it to adjust its orbit or adjust its trajectory. But if you had a spacecraft that's a light year away, it takes a year to send a signal to it and another year to get an answer back, which is not very interactive. So we're going to need autonomous navigation in order to get to Alpha Centauri. Then the last problem, of course, is getting any information back. Think about it for a moment. You're in orbit around Alpha Centauri, which is 4.3 light years away. You need to send information back to Earth, but you have to aim your laser where the Earth is going to be 4.3 years later. And so just think about the computation you would need to do in order to get the signal into the right vicinity for it to be picked up. So we turned to the Lincoln Laboratory, which is an adjunct of MIT, and we asked if they would help us figure out how far away we are, you know, both conceptually and mechanically from being able to mount such a mission. And there is a report that was given at the internet, the IPN-SIG webinar, or at an IPN-SIG webinar, which you can watch at this live stream. It turns out that we are 53 dB away from being able to solve all the problems that would permit a successful mission to Alpha Centauri. So that's a factor of about 100,000. So we have a lot of work to do. That's the last slide. I'm happy to answer questions, as will some of the others who are here today representing IPN-SIG. So I will stop sharing the screen and come back to the regular conference call and invite questions or comments. I see that there's already something in the chat here from Donald. Let's see. Oh, that's interesting. Okay, this is a disaster recovery idea, and we're very happy to hear that you're considering using DTN for that. I'm a big fan of that kind of use in terrestrial applications. I see that Amelie also suggests that this kind of communication might be useful for last mile, especially telehealth applications, and we also are excited about that, as I know Oscar is. I see Oscar makes that comment already. That's good, so the two of you can get hooked up.
Peter,
Okay.
I am also just shared about disaster recovery project from Alberto, just shared the link.
Yes, thank you. Let me just ask whether there are any other comments. Let me just point out something that I hope that EuroDIG will give some thought to. If this actually happens, if we really do build an interplanetary backbone, it will grow in the same way that the internet did. There will be applications that make it useful and parties who wish to have that capability in place. But the question about how it will be managed and governed, how it will be paid for, what is the role of commercial operation? That's one set of things about just the network and the communications. But think also about what happens when we start asking questions like, what does private ownership mean off the planet? Are you allowed to own a piece of the moon? Can you own a piece of Mars? What does that even mean? What are the terms and conditions? How do we cope with bad behavior in space? I mean, what do we do about it? Can we avoid militarization? These are all huge, very complex policy questions. And the way in which we have treated Antarctica does not work, in my opinion. Antarctica is considered to be a place that we want to keep pristine. We remove trash that's generated by human occupancy on Antarctica by sending ships, for example, to McMurdo, and we take tons of stuff away so we don't pollute that continent. But that's not going to work in the case of the rest of the planets and moons and asteroids of the solar system. We're going to have to imagine what it's going to be like to populate our solar system, however lightly, in a commercial context. And so the rules for that operation are going to have to be invented. Think about what we did with the law of the sea. Part of that law involved what to do with salvage rights. I mean, if you encounter a wreck, who owns the resulting salvage? I don't know that we have any agreements about that with regard to to space. So these are just some of the really interesting problems that we're going to have to wrestle with. It's kind of like living in a science fiction story, except that it's not science fiction.
I see that Marco has his hand up. Maybe he's up for the question.
Sure.
Yeah.
Go ahead.
Thank you very much, Vint and Oscar, for the presentation. I have a question about the use of DTN for these small satellites like CubeSats or nano satellites. Because the issue there is not distance, right? But it's the fact that there's few of them. So
it's also connectivity, which could be a
Right.
potential issue because you don't necessarily have continuous connectivity. So absolutely very appropriate for small sats. Yes.
is there some activities in that field already?
Well, the OPSAT activity is a small sat implementation. I think, Oscar, am I correct in that?
Yes, Vint, absolutely. And I'm going to share now a link of the experiment that we made with OPSAT, so Marco can read about that and make comments for sure.
Super. And final question. And is there any application for that? I mean, more than experiments. I mean, are people using that for?
Yeah, yes, there are. And mostly it's at the moment, it's largely a messaging application in use on the International Space Station. The astronauts are using DTN bundle protocol on a regular basis. Some of the experiments on board the International Space Station are sending their data back and accepting command and control for the experiments. I want to distinguish command and control of the spacecraft and the station from command and control of the experiments. They've not adopted the use of DTN for command and control of the International Space Station, but for the applications on board, the experiments on board, it is in use. So I wouldn't say that this is large-scale application, but we're exercising the protocol on a regular basis, which helps give us confidence that it will work in a scaled-up environment.
How are we going to do with the questions? I can volunteer for forwarding the question and reading from the chat. If you have questions in the chat, maybe preceded by a word question. Is there?
Okay, I'm just looking.
Eunice, you have your hand up.
Roberto, let me
Yeah.
ask you. Oh, I see. Yes, Eunice, please go ahead. I see your hand is up. We can't hear you yet. It's funny, you are unmuted, but we're not hearing you for some reason. That's annoying, isn't it? Do you want to try typing into the chat as an
Maybe the
alternative?
problem between your mic and your computer.
This is sometimes a problem with headsets because the computer gets confused about whether it's which microphone.
Okay, now.
Yes, yes, we can hear you now.
Yes, we know. Sorry. Okay. I want a little question. It's for you, Vince. I see you in LACNIC in the interview in this event in LACNIC 36, and only in my head I think how to sensitive my institution to start working in this great project. And in session preview with Oscar Garcia, thank you for inviting me. And we're talking about the project. With a colleague, Oscar Gutiérrez of Uruguay, he talking about the Dtn is interesting to work in IoT, but something that I have in my mind is how to sensitive to my institution. And ideas to have give me Oscar is working with a group, a little group, to initiate to these proofs with service databases, and but in my institute don't have this vision, but I want to. They have that. Why? Because I think I can can't work alone. We need another researchers, investigators to help. Because he is specialized in another areas who helped me to the goal, o sea, llegar al realizar el proyecto, ¿no? Perdón.
Develop the
Okay.
project.
Yes, develop the project. Sorry, I'm nervous.
Yeah, not a problem. Oscar may have some good answers here, but first of all, if I've understood correctly, you want to know how you could engage with this with these activities, and Oscar is absolutely the right guy to talk to about possibly becoming part of one of the projects or inventing a new one. And if you're wondering, how do I get colleagues interested in this at your university? A couple of suggestions. First of all, get a copy of the report that the strategy working group sent out, just to give your colleagues a sense for what we imagine could happen over the course of 100 years. And also to emphasize that we're at the very beginning, which means that there's lots of opportunity for ideas to be explored. The primary question is, what can we do with delay and disruption tolerant networking in this very challenging environment? How do we translate what we've learned to do in the low latency internet into things that we might want to do once we are proliferating activity across the solar system? So these are big challenges because the parametric space is so different. So if, for example, the network management concept had to be completely rethought because of the variable delay and high disruption. So when you start thinking about all the applications that we are comfortable with today, what do they look like in this environment? They certainly don't look very interactive. Although the one thing that you could imagine happening is the moral equivalent of what are called content distribution networks. on this planet, we recognize that interaction, even terrestrially, can be sluggish. And so we push information as close as we can to the users by building networks and servers like Akamai and Google and Netflix and others have done. So you can imagine doing something like that for the solar system. So what does an interplanetary Akamai look like? And how do you get the information out through the system? So those are just examples of the kinds of things that you might ask your colleagues about, and it tickles their imagination.
Okay.
I would like to add something. Eunice is professor in specifically in the biomedicine career, and they work a lot with sensors. And you remember that we have been exchanging on that. So I am very happy that she could attend here because we think that sensoring with DTN connected is going to be something very important in space exploration and also in Earth to get information, not only in healthcare, but healthcare is an area. So the career that she is involved into, and she's a professor, is very interesting in that way.
So this is an inverse example of the content distribution thing. This is content collection. When you need to get local information about the health of the astronauts, you need to accumulate that, and then it needs to be transmitted back to Earth for evaluation. So this is the other side of the picture. Roberto, you have your hand up. We have 3 minutes left. I think you get the opportunity to have the last word.
Oh, sorry. I thought we had 90 minutes.
Oh, did I misunderstand that? I apologize. I was rushing my presentation thinking we had only an hour. If we have more than this, of course, we can go on as long as you like.
And
that doesn't mean that I'm going to use the remaining 32 minutes. I just have a quick consideration, and then if you want to further explain, further go on in your presentation. I'm looking at these things a little bit with the eye of the history of the internet. I'm thinking about the early connection between UCLA and Palo Alto, and sort of one case that is very specific, and even now the applications that I see, even the reindeer application that I've learned so much at the EuroDIG this past summer, is still something that looks like a proprietary communication network, and I'm thinking about the evolution in the same way as you, Vint, didn't probably foresee, at least not so clearly, the commercial internet. There are lots of ways in which an interplanetary network can be used. I'm thinking about, for instance, communication among satellites that are belonging to different companies that do, I don't know, get data related to spying. No, that's not a good example. For instance, weather forecast and all these sort of things. It may be very useful to be able to federate those efforts and to have a network, but then you need to have people communicating on this. And the moment that you have people communicating among this, then you have a question about the governance of the issues. So
Exactly right.
Now, the point, considering that we are in the framework of EuroDIG that is about internet governance, I think that in the future, we might want to address, for instance, at EuroDIG next year, some issues that might be strictly related to problems about future governance of the internet. Because if you think about this things too late, then somebody else might have taken decisions that will force us to go in path that don't follow the needs of all the communities that might benefit from this interaction. So my question is there a thought in the community, in the Interplanetary Network Special Interest Group or in other groups about how to lay the foundation of an internet governance so that you don't have to go in a hurry to figure out things when the barn is already open?
So two things. First of all, I checked my calendar and my staff only allowed me an hour. And so I'm going to have to jump off to another meeting. So I apologize, but if you want to continue the conversation, obviously you can, but I will have to drop off. The second thing is that there is a governance working group, which we are just beginning to populate. And we are very interested in having participation from others, including EuroDIG. We've also invited other organizations, including NASA and ESA and Blue Origin and others have been invited to participate, so we can get a sense of how would this possibly look? How would we manage a federated and space-based network? So I apologize again, but staff only thought this was an hour, and so I have to go to another meeting. But I'm sure that you can continue on if you have an interest in doing so. And Oscar, if you're able to stay, you could be our IPN SIG representative for whatever is remaining, if that's okay.
Thank you. Thank you.
Okay.
I can stay sometime more. Absolutely.
Okay. Okay. Apologies for the timing mess up, but these things happen. But thanks so much for letting us share an hour with you. This was a lot of fun for us, so we appreciate that. Bye-bye for now.
Bye-bye. Well, we can continue the conversation. We have Samo here, and if you wish to make some comments, and Samo and Eunice, I guess they are both connecting sensors and all that. So I think, do you have some kind of presentation available, Samo?
Now that it's for the group.
No, I was asking Samo.
Sorry.
Yeah, no, I don't actually have maybe a presentation, but I mean, one thing that I would like to point out that I think it's quite relevant as well is, especially when it comes to internet governance topic, is actually, if I think when we start to deploy network first in the Swedish mountains with the raining herders in 2009. I think what's changed as well is just how internet services work. So majority of the internet services, and that's something that me and Oscar were discussing just yesterday, how more and more things are getting centralized. So for instance, if during that project we could still use the podcast, today everything is streaming, and it's kind of more and more things are actually getting really, really centralized, which makes the use of DTN, I think, more here in for terrestrial application a bit more challenging. So I think that is actually maybe one point that it's worth maybe to take note, just where and how the services are being developed today as well. So just a short note. Yeah, Oscar, you're muted.
Still muted.
Oscar, sorry, we can't hear you. You are muted.
I was changing something in my screen. Sorry. I think that, and I know Boston also has been working in Boston works in the case and with sensoring in DTN. So I think they can also make some comments. I was putting up also some of my presentations about medical records in space that you may, if we have time, I can show. But Perhaps it would be interesting if they both make some comments, Bogdan, Rasic, and Marija. Would you like, Bogdan?
Just a second. Okay. I guess you can hear me. Well, I'm thinking about, I have a different question, practical. If I would like to send some data, from example, from our caves to Samo, to the reindeers, or vice versa, Samo would send me some data from reindeers to the cave. Is there some bare bone network where we can meet, or where we can start to exchange? Is there some how do you say, backbone? Someone help me, please.
I think that we can do that perfectly. What implementation are you using, Bogdan?
We are still using the implementation that was developed in the M4C project. It's named Prophet, and now it's renamed to Pluti. But we tried to put this ION implementation on our embedded computers, but it's not, I cannot compile it because I'm using the OpenVRT Linux, which is really restricted. So maybe this EBR Dtn might work on our devices. I'm not sure.
We have compiled in Ubuntu, and I have made it run also in Red Hat and in CentOS, in the free version of Red Hat. And in the project of the offset, what we did is connect between D3TN implementation that also may be useful because it's not so heavy, and we could make some experience. Would be great if we can make some experience on that. I would be very happy to do that with you, with Samo, and we have also a group in Utica College in the United States. Utica is in New York State, far up, so we can make like a triangle or square between the different implementations, connecting and sending information between us. I'm going to help Eunice in the next weeks to set up also in some of their computers. I want to engage Roberto sometime for him to remember his times as programmer to join us. This would be a good idea, Bogdan, to start sending bundles at first and then put some real information on there. I think that would be fantastic.
Yes, I also think from our side it would be also interesting to go further, to start joining different networks now.
Yes, that has been my idea from the beginning, and I know Vinton is very excited about that and all the agency, because from my point, what has been happening all these years is that this has been developed by the space agency for their specific projects. For example, for communicating with the satellites or the spacecrafts to get information from space, and that's great. But we are in a different stage. Like Roberto may remember, when the internet started, it was only for defense and later. Now we are communicating the civil society with the internet. So I think that's the important point, and that's why I am pushing also the medical records and different type of applications to be useful for normal people with Dtn. For example, 3 years ago, we developed 20 years ago something like a Dtn, but was based on TCP/IP. That's why when I started talking with Vinton about this in 2005 in ICANN in Mar del Plata, it was so easy to understand because 3 years ago in the fires in the Amazons, our medical records was working there even without communications, because when the communications stopped, then the antennas of mobile antennas fell, went down, and so DTN applications are really useful not only in space but in Earth. As I always say, sooner or later, if we have our relatives living in space, we would like to communicate with them and send pictures of our kids, for example. So we need this to work.
And if I can add, like, I mean, yeah, we do have, just short like note, we do have kind of a network or this backbone slowly being built up, as Oscar said. Like, I mean, it's Ronnie at Utica, he's kind of building quite a big network. So, but unfortunately, we're still quite fragmented. So we run a couple of experiments, and then parts of the network goes off. And so it's not permanent. So it's quite a highly fragmented network, although it's slowly started to build up. So I think we're adding more and more nodes. So it would be good to kind of start some permanent experiment.
I wonder whether you know, I'm going back to the question about the communication between Samo and Bostian. Whether we need to figure out whether some of the what I can qualify as local area network that are the ones in the caves and with the deers can at a certain point in time be linked to the backbone internet, and then have communication flowing between those two local networks using the internet, and what are the limitations and constraints in doing this, and of course, what are the governance issues that raise among this. I mean, I don't think that we can have a planet-wide DTN delay-tolerant network that replace the normal internet. I think that we need to sort of federate the two environments to try to you know, use every part of the network and every type of network for what it is best at. So I think that the interfacing between the two, like for instance, you know, issues about DTN, DNS queries and so on, needs to be solved in order to be able to provide good communication. Anyway, that's the question. I see Maria.
One answer about that, Roberto. When we started making experiments with Samo, with Ronnie in Utica, and the Albertos in the United States and in Spain, we thought the thing the same way as you are thinking it. So what we are using nowadays, we are running over the internet, but with bundle protocol. So the bundle protocol is running over the internet, utilizing UDP to make the connections. Even we have computers like laptop computers, very small and normal, running, for example, a virtual machine, and inside that virtual machine, running Ubuntu Linux, there's ION running to send bundles and connect with each other. And And this is connected, for example, by a DCL or a cable, a regular home computer. So that is working.
I see Maria has her hand up.
Yeah, I wanted to comment on Samuel's note about centralization of everything. It's true because cloud computing makes things centralized and it's pushing towards centralized things, everything. And the problem is that we have to, if we want to develop DTN for terrestrial applications further, we have to find issues that cannot be solved by cloud computing and normal internet. So if we found more of that ones that needs another kind of solution, then this will go further. It will be a natural development then. Otherwise, for the research purposes, we can make test beds and so on, but it's still kind of artificial. But if there are applications that really don't need, that don't have other solution, then this will take things further. And this will also maybe bring some commercial interest, a real one, into the subject.
I absolutely agree. We were talking yesterday with Samo exactly about this topic because I commented that our development in medical records, we are now distributing in servers all around instead of being centralized. But you know what the problem is? The problem is to think the architecture from the beginning to be distributed. Because if you architect from the beginning with a centralized model, it's quite complicated. You have to divide it later, and you know you have only one database. You have no that.
If you have
you have to have many distributed databases, and that's finally the goal, to store the information, and then you can connect all that distributed system. Commercially, for the big companies, it's much better to centralize it, and I think that's your point. But it's not so useful.
Yeah, the problem is the price for this. The price will rise for the storage, and the price will rise for the routing protocol to be developed in such a way that it can serve all the purposes, but that's very hard to do it.
So sure.
Yeah.
I think you have to be alert not to step in the situations with the when you have to preview.
Yes, definitely.
You have to preview, because if you say you are, for example, I'm going to I'm not going to send brand names, but I'm going to set up this database that it's very costly. Sooner or later, you even if it's free at first, you are going to have problems later.
Yeah, and if you just think about, you know, the current Facebook outage, I mean, that really spoke for more distributed and argue for distributed systems, because I mean, it showed how, I mean, vulnerable we are. I mean, just because, yeah, one social media that's being so centralized, I mean, and so many services were down. So I hope that, yeah, I don't know, the more often this happens, the better it is for DTN, because it's, or for other distributed systems. I mean, one point I would like to make as well, if you talk about, you know, interconnecting like different networks that are already built, is that how we are doing it up here with Reiners, because there we have really limited system, you know, how much data we can send. We cannot afford to really send big packages and stuff. We have really low bandwidth. So we actually have a gateway where we have a translator between one network to another. So what you can do, for instance, if you're using the ION implementation, you can define so-called gateway endpoint, and that one can actually take more addresses and actually then distribute it in your local network. So it's like, actually, I'm doing a lot of translation on our gateway, and there we actually interface with the bundle protocol, actually, with the bundle protocol version 7. So, and that's how we then further connect with the IPNSIC network.
Well, we very
Let
active.
me take just this a blank space. Nature abhors empty spaces, so I jump in. To note that the EuroDIG Secretariat is offering to provide limited secretariat services and inviting us to join those who are not already on the mailing list to continue this discussion so that we can after this conference maybe continue the discussion. Sorry for interrupting you, Oscar. Go ahead.
No problem. I love this talk that we are all having ideas. And Roberto, I was thinking that if you have the I have to look for it, the link for the strategy report of the towards the solar system internet. I think that most of the attendees would be happy to read it or have it available. I can email or Daniela can email that later for us, for everybody. But I don't know if everyone has. I am saving the chats, but if everybody wrote their email addresses, so we can expand. Your DTN group is growing big, Roberto.
Yeah, it's not my DTN, and actually is linked to the 2021 EuroDIG. I hope that we will be able to organize a working group for the session at EuroDIG 2022 that is going to take place hopefully in person in Trieste. And I think that DTN has shown so much interest that that is worth having a session over there, and maybe at that time we can organize a side trip to Postojna to see the caves and one practical installation of DTN.
Yeah, we are planning
fantastic.
to Trieste also. So Roberto, you can count on us. We will come to Trieste if you organize. Okay.
I also see in the call to Juan Morea, who is a friend, but he's in Porto Alegre, Brazil. So we are very international today.
Who is from Porto Alegre?
Juan, are you there?
Hi, people. I'm here. Yes, and listen to your meeting.
I was wondering if Sandra wants to say a few words to close this session. I think we are 6 minutes away from the end.
Thanks, Roberto. Actually, it was such a fun to listen to you. From the topic, I understood only half of it because I'm not a technical person, but it sounds like something that could be the next big thing. And to be honest, from the EuroDIG perspective, I was very proud that we could host this discussion. And if this is the beginning of a collaboration of a DTN group, that would be cool. We never had something like this within EuroDIG, but why not starting with such a futuristic topic? And as I said already, we will be more than happy to support if this group would like to continue with calls or on the mailing list or provide space on the wiki. And as Roberto mentioned, it would be, of course, desirable to meet in person in June. We are looking into the dates around the 20th of June next year. So maybe mark that week in your calendar, 20th onwards. We will stop before midsummer so that the Nordic people can go back to celebrate midsummer. But yes, indeed, that would be really good. And if there is something to look at in real life, and as you say, something, an example, an excursion, why not organize something like this as well? We are open to all of this, and you are most welcome to join. And I think the easiest way is if you just subscribe to the mailing list. On this mailing list are potentially other people that are interested in the topic. So you could hold regular meetings, I don't know, once a month, every half a year, or whatever sounds suitable for you. And also our social media channels, yeah, like newsletter and so on, can be used if something is of interest for the entire community. I think it's a pretty new topic still. Only few people have knowledge about it. But this is what EuroDIG stands for, to detect early topics and promote them and give communities a chance to develop them. So feel most welcome to be part of this EuroDIG community. I know almost no one of this call, and this is really great. I mean, usually you have same usual suspects, but here there are totally new people, and that really amazes me and makes me very happy. So also thank you to Roberto and ICTP for organizing and for coming up with this. For me, that was really a great experience.
Well, I think monthly meetings can be a little bit too much, but quarterly meetings or something before the Trieste conference would be very suitable.
Absolutely. Whatever you find suitable, we are happy to accommodate that.
Sandra, I can say that I am also European because I have a Spanish citizenship. So I would be very happy to attend and follow up with the and I'm we are, as I said in the chat, we are very open to everybody join IP&SIG. I will email some instructions because you have to join the ISOC first. There's 2 steps, and our project working groups, we're open to anybody that wants to come. We have meetings every 2 weeks, but we exchange a lot and have a lot of activity. So anybody in the call, we would love to hear from you.
Thank you very much. I think that we can close now this extremely interesting, at least from my point of view, session. Thank you, Oscar, for taking then the relay after wind, and thank all the participants. It's getting really dark where I am. I need to turn on the light. Yeah, thank everybody for coming. And I think that if we have ideas, we can develop that on the mailing list. And let's make sure that we have a wealth of ideas when the time will come for throwing in proposals for EuroDIG 2022, so that we can gather the interest also beyond this small group and get the interest of the community. Just I want to mention that I was on an ICANN meeting. There's the ICANN prep, ICANN 72 preparation week, and there was somebody who was talking about DTN in the chat, and I was sending the information that EuroDIG had this session and so on. So there are a lot of people, I think, that around there that might be interested in joining some DTN activities, but just don't know where, how to connect and how to get involved and so on. And so EuroDIG could be a moment also for accruing this interest into a group that can be helpful. As usual, I have been speaking too much, and maybe we can just say hello unless there are some final comments. Okay, thank you all for.
I want to say that thank you very much for organizing this. And from IP&SIG, we are very grateful.
Okay, bye.
Thank you.
Bye.
Bye
Thank
bye.
you.
Bye.
Bye. Bye. Thank you a lot.